everyone. I'm Jeannie Northrup. I'd like to welcome you all to today's webcast, Optimizing cGMP Facility Design Space with a Hybrid Approach. Today's program is presented by Biopharma International and sponsored by GCON. GCON specializes in the design and construction of advanced clean room solutions for a wide range of industries. They work closely with customers and A&Es to provide solutions that meet their specific needs, building what are known as modular clean rooms offsite, and providing modular and hybrid construction options. Before we begin with today's webcast, I have just a few important announcements I'd like to make. This webcast is designed to be interactive. We encourage you to ask questions based on today's presentation throughout the event. You can submit any questions you have by typing them in the Q&A box. That can be found at the bottom of your video player. For viewing purposes, you can enlarge your slide window by clicking on the small icon located in the bottom right corner of your media player. Please note, however, that all slides will advance automatically throughout the event. If you do happen to experience any technical problems viewing or hearing this presentation, please click on the question mark help widget located in the top right of your presentation window. I would now like to welcome today's presenter. Joining us today is Dennis Powers, who serves as a Senior Vice President of Product and Strategy for GCON. He's also an active member of both the International Society of Pharmaceutical Engineering and the Parenteral Drug Association. He joins us with 30 years experience in the biopharmaceutical industry, having supported roles on both the client and supplier sides of the business. He's held various technical and senior management functions in engineering, operations, project management, sales, and marketing, and has helped support companies through the development of various innovative, value-added facility and process strategies and solutions. Dennis, thank you so much for joining us today. We're really looking forward to your presentation. Feel free to take the floor.
Great, thank you, Jeannie. So today we'll be discussing an optimized construction approach for executing biopharm facility capital projects more efficiently, in less time, and with a high level of budget and schedule certainty. We'll start with an overview of the typical drivers, risks, and requirements for biopharmaceutical projects, and then we'll examine and compare 3 different construction methodologies for executing these projects, with a primary focus on clean room infrastructure. Then through exploration of the clean room design space, we'll show how these methodologies can be combined into a hybrid approach for project execution. And then towards the end of our discussion, we'll review examples of 3 different projects that have been successfully implemented following this approach. So before launching into the details of the presentation, it's important that we align on the terminology that we'll use throughout the discussion today. Stick-built is the traditional approach where all construction takes place at the project site location using common materials of construction, including gypsum board, studs, epoxy paint for building the clean room infrastructure. Modular panels are an approach that's used where the architectural and clean room envelope panels and components are manufactured off-site and then shipped to the project location for assembly in the field. Prefabricated modules, that's where the majority of the clean room infrastructure is fabricated at an off-site factory, tested, and then shipped to the project site where it is installed and goes into final assembly in the field. And the last one is the hybrid approach. And in the context of this discussion, hybrid is the combination of 2 or all of the 3 methodologies mentioned above in order to optimize the construction of a clean room project. And here we see some photos of what each approach might look like for a given project. On the far left, you see the stick-built approach, which is as you would expect. It's a typical methodology. It's construction that's used for critical environments and clean rooms, as well as non-critical areas of the facility like office and administrative space. In the center, we see modular panel construction. And you can see that the clean room envelope is reliant on the host facility structure for structural support, as is the ductwork and piping, which typically runs back to a large mechanical area with air handlers, chillers, and other support equipment. And then on the right, you can see what a prefabricated approach looks like. In this case, the clean room pods are delivered to the site near completion, fully integrated with HVAC and mechanical controls, electrical, and they're able to be rapidly moved into the building and then into their final position. Note that the prefab units are structurally self-supporting from the concrete slab below and are physically independent from the shell building structure. One thing to note as well is on the prefab side, you do not require all of the laydown area that you do for the stick-built and modular panels. The laydown area is required for storage of all the materials while waiting for installation to be completed. So now let's take a look at capital projects in the biomanufacturing space, which are often highly technical and complex. And there's a number of factors that drive the project complexity. Containment and segregation is critical for meeting cGMP regulations that require manufacturers to consider all sources of contamination and create control strategies in order to protect the product itself from contamination, and in many cases also protect the operators and the outside environment. Many of these strategies result in engineering and facility controls that create the appropriate personnel and material flows, as well as ensure the appropriate segregation by match and or modality if it is a multi-product facility. All right, and these engineering controls include facility designs with the proper adjacencies and directionality, as well as robust HVAC systems that can consistently provide the specified environmental conditions, airflows, and pressure cascades. And if the facility is going to be used for sterile manufacturing, then these processes also require an extensive network of clean utilities, which are distributed throughout the facility, and which need to penetrate the clean room boundary in various locations. These penetrations, along with all the other architectural features within the cGMP footprint, they must be carefully considered when designing and creating that envelope. The cleanability of the clean room is also fundamental and dependent on these architectural finishes. Because of the high complexity of these facilities, the time for engineering, design, construction, and qualification is often significant. Historically, a new greenfield facility could take up to 3 to 5 years till it's operationally ready, right? So this also all has to be considered in the context of the business case and the mission critical drivers for the project. Okay, and in almost every capital project, schedule is going to be a key driver. The timeline and speed for executing these projects, informs the engineering economics and may serve as a go, no-go decision for some construction methodologies. Items that drive schedule can include time to get a manufacturer's drug into the clinic. It could be trying to get a new product first to market. It may be in response to a drug shortage situation as well as a pandemic, as we saw with COVID. Market authorization can also be a driver and is dependent on location, which will heavily influence the design, execution, and regulatory strategy. Product modality is important, right? Will this be a single product facility, or will multiple products and modalities be produced within the same facility? When we're talking about multimodal facilities, there's a much higher level of complexity, especially related to segregation and containment that needs to be addressed. Throughput and scale are also very important, and the project team needs to look not only at the short-term throughput requirements, but also at the longer-term needs to ensure that the facility design is properly future-proofed for capacity increase or scale out in the future as market demand changes. And of course, all of these process, business, and regulatory considerations need to be considered by the end user with support from the appropriate consultants and solution providers that are part of the project team, right, in order to help properly navigate the drivers, all of which will, of course, influence the key driver that you see at the bottom, and that's the capital project budget. Now, in parallel with the drivers, the project team must also consider the risks very early in the project planning stage, right? And proper understanding of these business risks and their impact will certainly allow for better decision making and help educate and inform the project execution approach. Delays to project schedule, which will impact timing of operational readiness, can often have adverse effects on the business if there are delays to market or clinic, or there's a supply shortage. It's therefore important to assess how much tolerance your project and business objectives have for delay. In this context, clinical and commercial financial success is inherently tied to the overall success and timely delivery of a project. In addition to delays, it's important to consider potential for client-side changes as the project evolves. The data set and the information that the clients are working with will be evolving as well, especially if the products they're going to manufacture are in clinic. Forecasts may change, which may drive process changes related to throughput and scale. So understanding these risks and the probability of occurrence for these items is important for manufacturers to consider in order to select a project execution approach that's going to help mitigate those risks. Now, once the project team is able to assess those drivers and establish the risk tolerances, they can then chart the course for project execution. And in today's industry environment, many, if not all of the projects being considered have very common goals and objectives, all of which can be achieved with a hybrid approach, right? This pathway allows for projects to be executed faster with a higher degree of certainty and cost, while at the same time also ensuring the highest levels of quality. We can maintain the flexibility that clients need as they work through the changing landscape during front-end planning. With this approach, we can find a solution that allows for scaling of the facility without interrupting the on-site operations. And we can do all this in a way that can also help address some of the local construction resource issues that we're seeing within the industry. Local resourcing, skilled labor is often a bottleneck in project execution. And that's one of the reasons why modular and prefabrication construction has gained a lot of interest within the industry. These approaches are not new, and they've continued to gain recognition across multiple industries, in fact, right? But what often happens is that these different methodologies are compared against one another in consideration for a capital project without adequately exploring the design space for opportunities to optimize, right? And there are many projects that can benefit from a single approach, a single construction approach, but oftentimes the optimal solution lies in a combination of these methodologies within a hybrid project delivery approach. So as a project team, it's important to understand the strengths of each of these approaches in order to leverage the benefit in the appropriate areas of a new facility build out, right? So the table that you see on the right on the screen here, it's a high level qualitative assessment of the various factors that should be considered for each methodology. As you can see, there are areas where the stick-built approach is stronger, especially in those areas related to, its history and the extensive knowledge and experience-based that we have, as well as its flexibility. But it does rate lower in a number of areas, which can bring risk to a project. Conversely, prefab, while its history and knowledge base may be lower than stick-built, it does rate very high in certain criteria, specifically around project duration, depreciation, transportability, as well as cost and schedule certainty. And then, not surprisingly, the modular approach kind of falls right in the middle between both stick-built and prefab. Now, the impact of the factors here, they really need to be weighted accordingly for every project based on what that project's drivers and risks are, right? And the goal here is to leverage the strength from each of these respective approaches in order to provide the most optimized solution for the project. And once the project team's familiarized with the different methodologies, the users and the designers can then start exploring the design space to see how to optimize the design in order to achieve the highest performance and the lowest total cost of ownership for the facility. Right? When we look at a project team, you have your end users, the manufacturing team that are going to provide the user requirements and the inputs. The engineers and designers will then provide solutions for the critical and controlled environments within the facility. And as you work through those different inputs and criteria, you may find that maybe there's a high level of flexibility required. So maybe going all prefab isn't the right choice for the design space. Maybe if it's a retrofit of an existing building, the modular panels aren't able to be supported from the facility structure. So you may have to go with prefab that's self-supporting. And then for many projects that are fast track and schedule critical, maybe stick-built isn't fast enough to meet the project requirement. So, evaluating the project with the intent of leveraging the benefits of a combined approach can really drive towards the most optimized solution. Right, so in order to illustrate the approach, let's now consider a generic cell therapy layout, which incorporates 2 process suites, the CT suites, as well as an entry locker space, QC labs, as well as a material handling area on the far right, right? So, and once the project team establishes this general schematic layout for the clean room area, right? Historically, the next step would be to generate, an individual cost estimate for each approach based on the project requirements, right? And, traditionally it would be a estimate for a prefab solution compared to an estimate for a modular clean room solution, compared to then the third option, the stick-built solution. So what we're suggesting with the hybrid approach is to not look at it as an all or nothing single solution approach, but rather assess each of those potential options with the intent of applying the best methodology to the specific needs of those different areas. So if we look at a couple different ways to look at this particular example, in one way, we can utilize prefabricated clean rooms for the most critical classified areas, the grade C and D that you see in light blue here. And then we can utilize the stick-built approach for the non-classified areas, right? The locker room and the QC lab where we don't have any manufacturing operations taking place. Another way to look at this would be to use a combination of all 3 methodologies, right? Here you can see that we're maintaining the core grade C process areas as prefabricated clean rooms. But now we're also using a modular approach or methodology for the grade D and C areas, which are the labs as well as the logistics and kitting areas on the far right. And then we're still using stick built for the non-classified locker room area, which is the least critical area. So, so this is just two examples of how you can take a schematic and look at it through the lens of a hybrid solution, right? And again, in the end, the most optimized solution is the one that best addresses the project drivers while also mitigating the risks of the business. So when we talk about risk, from a quality perspective, it's very important to identify the risk and criticality of each of the areas within the facility to ensure the proper quality and controls are put in place, right? So this includes risk to the product. Is there any direct product contact in the specific room? Is there any open processing taking place? To establish those room-based requirements, right? The other key question is there a health or safety risk to the operators within the clean room or to the surrounding areas of the facility? Is air leakage from the process areas acceptable, or do we need to design the facility and the rooms for containment? So we can use quality tools like FMEA, where we can quantitatively score each area in our manufacturing facility to help determine the best construction approach for each, right? So if we take a look at two examples here, which are two independent rooms within the same facility. On the left-hand side, we see an inoculation suite, which is a critical area as it provides the necessary background environment for housing a laminar airflow hood where aseptic manipulations are taking place. So a very critical part of this particular manufacturing facility. On the right-hand side, we see a final product or API release storage suite. This storage area is less critical to the manufacturing operation because the product is fully enclosed and safe from the environment. It doesn't include any critical process equipment or manufacturing steps, and it's not a highly classified area. So through a very basic and straightforward risk assessment, it can become very clear that an area like the inoculation suite is more critical, requires a higher degree of performance, and may benefit from the advantages of a modular or prefab approach, whereas the API release storage area, less critical, and you might be able to either use a modular or a stick-built approach, right? And this type of logic can be expanded for all the remaining areas within the facility to help the project team fully flesh out the design schematic. There are other quality-related risks that have to be assessed related to the clean room build, such as materials of construction. When we look at traditional stick-built construction where epoxy painted gypsum is used, oftentimes the final finishes are really not optimal. The materials of construction don't hold up well over time under the cleaning regimens that are required in these critical environments, and that often results in significant ongoing maintenance expenses. Ideally, newly constructed clean room environments should be built with polymeric architectural finishes throughout the entire envelope, like those that are provided in both modular and prefabricated clean room solutions. The facility contamination control strategy also needs to be considered when selecting materials of construction. For those that are planning to sell their products in the European Union, right, this is now a regulatory requirement within Annex 1. Right, so the capabilities of these polymeric surface finishes on metal structural components really strongly support cleanability and microorganism growth inhibition found in most contamination control strategies. The last risk that we'll touch on here has to do with the skill set and experience of the labor force constructing the critical clean room environments. Stick-built construction relies heavily on the availability of local skilled labor. And it should be noted that stick building a clean room is not the same as stick building a non-critical area like an office space. Modular suppliers often have dedicated teams that will mobilize to the project location with their own staff, but many times they also need to rely on the local skilled labor as well to execute their projects. And in certain locations, there may not be subcontractors experienced in critical environment construction. In other markets, the skilled trades may not be available due to a high volume of projects that are all running concurrently. The benefit of the prefab approach is that it has little to no reliance on local skilled labor, since the fabrication of the clean room modules are performed offsite in a factory, and the installation labor needed at the site is typically provided by the prefabrication clean room supplier. So as I mentioned earlier, project schedule is critical on almost every new clean room project. And with the inclusion of prefabricated solutions as part of a hybrid approach, these projects can be completed much faster than those projects that need to be executed fully on site. And this is realized through a parallel execution path that you see here on top, rather than a sequential one that you see on the bottom. And you can, when you are prefabricating clean rooms offsite in a factory, it allows you to build those clean rooms at the same time that the shell or the building shell is being constructed. When we talk about on-site execution, traditional stick-built or modular panel manufacturing, we're talking about a sequential project execution where the shell building construction has to be completed before you can actually start the clean room construction, right? So, and this really allows manufacturers to get to a faster project completion, which can again help them get their products to market faster. It's more efficient use of their resourcing. It really does reduce the project risk and helps also from a financial standpoint, get a higher rate of return on their investment. Now, the second way to look at this condensed project schedule is to look at it from a delayed time to investment, right? And this can also reduce the business risk by giving the manufacturer more time to collect critical data and information before they actually have to start the project construction, right? And that additional data information may be in the form of, additional clinical trial data, better market condition data, better characterized processes. So this type of information, when you are able to wait a little bit longer, can really, really significantly reduce the business risk, as well as preserve capital a little bit longer before you have to spend it. Now, historically, the different approaches for new clean room construction have been evaluated really solely on the upfront capital cost, and this selection of the approach has been based on which provides the lowest cost per square foot. And the downside of this is that it often incentivizes bidders on the project to exclude or diminish scope or value in order to win the project. And while cost per square foot, can be a helpful benchmark, it's really, really more important to look at it from a total cost of ownership standpoint. And total cost of ownership is, generally defined as the purchase price of an asset over the life of an asset. Now, this does take a little more effort in order to understand all of the costs that go into a total cost of ownership analysis. in order to generate the net present value, the internal return, as well as the payback period. Right. So, as a very simple example, we evaluated a 40,000 square foot manufacturing facility and compared the total cost of ownership between a hybrid clean room approach comparing to a traditional stick-built clean room approach. Right. So you can see here on this summary table that although the initial capital investment for the hybrid facility was a bit higher, we found that under identical project conditions and economic conditions at the same location, the hybrid project provided a more favorable economic outcome with a higher NPV, ROI, and a shorter payback period. And there's two primary explanations for this. As I said before, a hybrid solution will get a new facility to operational readiness faster compared to the traditional facility, which means faster realization of revenue and an incremental increase in revenue generation over the more traditional construction approach, which takes longer and delays that revenue recognition. The prefab clean room portion of the hybrid solution can also be depreciated within 7 years rather than the 39 or the typical 35 to 39 years that's used for a traditional depreciation schedule for a traditional construction methodology. So, when we look at it, again, slightly higher initial capital cost investment, but you're going to get a much better return on your investment when you look at the NPV and the ROI and payback period. So at this point in the discussion, we've reviewed the various construction approaches. We've looked at some of the design features for hybrid projects and some of the key areas that you really need to dig in deep in your evaluation. So now I'd like to just take a little time and show 3 project examples that have been successfully implemented. Each of these projects had their own goals and drivers. And in the end, a hybrid approach was selected as the optimal solution for each of them. So in example 1, this is a project that incorporated approximately 13,000 square feet of total clean room footprint. The application is for biologic drug substance manufacturing, including both the upstream and downstream processes. The key drivers for this particular project were schedule. They wanted to, this was actually for a CDMO who wanted to be operational ready very quickly within 18 months of the project start. They also wanted to minimize the need for on-site skilled labor due to some labor scarcity in their particular part of the world. And they wanted to incorporate flexibility into the design to allow for future scale out. So when you look at this facility layout here, you can see that all of the core process steps are taking place within these small prefabricated clean room environments, which are installed within a larger grade D modular ballroom, right? That facilitates the personnel and material movement to and from the core process areas, right? And within these prefabricated pod clean rooms, you have intensified processes being run that allow for production of monoclonal antibodies and other biologics at a commercial scale level. The other nice thing about this design is that it allows for all of the buffer and media totes to stay within the larger ballroom space. They don't need to bring totes into the small core process areas. All of the solution transfer is done with through wall connection ports. right? And you'll see on the bottom right corner of the layout is a future space to allow for expansion and add 2 additional prefabricated pod clean rooms, one for upstream and one for downstream. So this client had future proofing in mind when they designed this facility with the intent that they wanted to be able to rapidly scale out in the future when they needed to increase their capacity. And this is just a photo of the interior of that ballroom space with the prefabricated pod clean rooms incorporated. Now, an example 2. This is a slightly larger clean room space, approximately 27,000 square feet of ballroom that you see on the lower south side of the plan. And at the top, you see approximately 8,000 square feet of bolt-on prefabricated clean room pods, right? So a slightly different approach than we just saw in example 1. In this case, you have a large modular ballroom with the prefabricated pods that connect directly to that ballroom. Okay, and the key drivers for this particular facility design were flexibility to allow for multimodal production and campaigns, as well as allow for the rapid change out of manufacturing capability by connecting and disconnecting or replacing these prefabricated pod modules, right? So the design features were pre-engineered unit operations that have been pre-programmed into these pod modules for specialized manufacturing campaigns. It allows them to essentially plug and play these different prefab modules as needed for their different campaigns to support multimodal manufacturing. They've also designed the facility to be expanded in the future. So this light area you see on the lower right-hand side is for future expansion of the ballroom, where you could also connect additional prefabricated pods. Right, and again, you know, their key for a multimodal facility is to be able to minimize their downtime and provide optimum flexibility when they need to change out a campaign or go from one product type to another. Okay, and this is just a view of the entry ways or the entry airlocks into the prefabricated pod clean room from the ballroom side. And in our third and last example, we have a cell therapy application where we have a total of 30,000 square feet of clean room footprint. Now, the intent of this facility design was to really heavily leverage prefabricated pod clean rooms for the core critical process areas that you see in blue. And you then utilize modular clean room construction for the connecting corridors and support areas that you see in green, okay? And flexibility and scale out was another key driver for this facility design. It's a design that allows for installation of the prefabricated pod modules in phases. So a single bank of the prefabricated pods was installed as part of phase 1. And then there were additional phase 2 and phase 3 that followed on that allowed them to bring additional pod clean rooms into the building to scale out their operation as they needed to increase their capacity. So this is what we would call a clonable design, where you have a process suite that is replicated and added, and multiple suites are added to that building footprint as you need to scale out your facility. So in conclusion, I'm sorry, and here's a final photo of the access corridor to get into each of those prefab pod suites. So in conclusion, again, the design and construction of biopharm facilities is complex. Therefore, the manufacturers and their design team really need to clearly establish the drivers and risks early in the planning stage for their projects. Optimization of the cGMP design space really requires assessment of the different methodologies in order to come up with a solution that combines the best of all of those methodologies, right? And a hybrid approach is a good way to de-risk your project execution while at the same time meeting the quality standards as well as schedule and performance requirements of the project. And for those of you not familiar with GCON, we are a global industry leader in both prefabricated and modular clean room infrastructure. Our two business units, GCON, which is the prefabricated pod business unit based in College Station, Texas. And for the last 15 years, we have designed, built, and delivered prefab clean room solutions for our clients. We've done over 50 projects. We have over 400 pods installed globally, and we have manufacturing both the US and Europe. And then our modular business is our GCS. This is a business that was acquired in 2022 by GCON. The business was Place Europe, founded and based in Vonau, France. They've been in business since 1978, and they have a comprehensive portfolio of architectural and MEP modular cleanroom components. And we have manufacturing for the GCS Place Europe product line in both the US as well as in France. So thank you for your time today, and now I believe we'll open up the floor for some Q&A.
Thanks, Dennis. Yes, we will get ready to jump right into our Q&A session. Before we do, just a few important announcements. Obviously, running close to the hour and seeing the number of questions that we've already received from our audience members. Don't be discouraged if Dennis does not have a chance to respond to your question live today. Be rest assured he'll also be reviewing and responding to questions offline after the broadcast. And that said, please continue to ask any additional questions you may have. For anyone who would like to submit a question, again, you can type it simply by putting it in the Q&A box found directly below your video player. So Dennis, the first question, other industries can utilize 100% prefab methodologies for their entire project scope. Why isn't that, being proposed for the bio construction projects specifically?
Oh, thanks, Jeannie. Yeah, that's a good question. I think the primary reason that we see is that in some of these other areas where they're using 100% prefab, like hotels or hospitals even, a lot of times that these projects are really, they design, in the case of like in a hotel, for example, they have a design that they replicate at every single location where they need to build a new hotel, right? So they can really benefit from 100% prefab solution. With biopharma projects, right, not every facility is going to be exactly the same. Every area may have different requirements. So our experience has shown that most of the time for biopharma projects, the hybrid approach where you have a combination of these different methodologies, prefab, modular, and potentially stick built, is often the best approach within biopharma.
Well said. Something that we hear echoed across the industry with the development and manufacture of these more complex molecules. So Dennis, another question. Progress for on-site construction projects is easy to see at the site. How do you monitor this within the facility when it comes to modular and prefab projects?
Another great question. So at GCON, we've implemented a number of tools that help our clients track the progress of their project while it's in the factory. We use a tool called Smartsheet for tracking and monitoring a project's progress, and the clients have access to that Smartsheet throughout the duration of the project so they can see the day-to-day tracking of progress. Our team routinely sends project updates with photographs and videos, so the clients are constantly getting updated. And then, of course, our clients will typically come to our factory at a minimum for the FAT, which takes place right before the pods are shipped. But our clients are welcome to visit our factory and see the progress of their project firsthand at any time throughout the project lifecycle.
Thanks, Dennis. And I knew we could not have this presentation without at least having one question come up regarding safety and regulations. What do our listeners need to know about a hybrid approach and the impact on its safety measures?
Yeah, well, I agree. I mean, safety is paramount. It is the number one driver on all projects. It goes without saying. And I think what we've seen based on our experience, when you take a hybrid approach and you are able to fabricate, a large portion of the new facility infrastructure in a factory environment, which is well controlled, it really reduces the probability of safety incidences, right? On traditional construction projects, the probability of a safety incident is really dependent on the number of contractors and subcontractors that you have at that site. So when you reduce the number of subcontractors like you do with the prefab approach, you can really reduce your safety risk. And when you're in a well-controlled factory environment, you're working under, well-documented quality and ESH procedures. You've got well-trained staff who are doing this on a daily basis. So it really does, when you can prefab in a factory offsite, reduce the number of on-site labor that you need, you really can significantly reduce your risk of safety incidents.
Interesting, thank you. Dennis, we're going to get ready to wrap up with today's discussion, but I have one final question I'd like to address while we have you on the line. I thought it was a really great way to close out. Can these hybrid approaches be repurposed? So, of course, the question was the concern that traditional facilities are often, and I love this, mothballed after their project life cycle is complete. So, can this be extended or repurposed to utilizing a hybrid approach for other projects?
Yeah, absolutely. Certainly, if the hybrid approach or if a facility is built with a hybrid approach that incorporates prefabricated modules like pods, which can be actually relocated, transported in the future, that really does provide an extended life of that asset. They can repurpose those prefabricated pods for different use. They can move them to a different facility. So they can get a much longer useful life of that asset, as opposed to, if you build a facility following a traditional approach, at the end of its useful life, you are going to have to essentially decon and decommission that facility for its new use. So, having a prefabricated solution within a hybrid approach really does allow you to, retain value, at least for a portion of the assets when the project comes to the end of its initially intended life cycle.
Thank you, Dennis. Jumping into this discussion today, I actually was not aware of the specifics to a hybrid approach and how they differed from modular, et cetera, as you've mentioned today. So this was really insightful We really appreciate your time and your commitment, obviously, of long-term service in the industry.
Well, thank you. I appreciate that, and really appreciate the opportunity to present to the audience today on behalf of Biopharma International and GCON.
Thank you. That said, I'd also like to thank Biopharma International and GCON for making today's webcast possible. And of course, I'd like to thank our audience members for their time and interest in today's program, as well as your questions. To Dennis. Again, Dennis will also be reviewing and responding to the unanswered questions offline today. So thank you so much for participating. As we do conclude today's program, I want to ask if everyone in our audience wouldn't mind participating in a brief survey. The survey will populate on your screen after today's presentation has ended. We greatly appreciate your insight. You will also receive an email alerting you when this webcast is available for replay. We invite you to forward that announcement on to any colleagues who may have missed today's live event. Thank you so much to everyone for joining, and we hope to see you again next time. Goodbye.